next I want us to calculate the probabilities of specific events. So we're going to go over just these two things in section 6.3. So let's get started. It's a nice short section. So the probability of equally likely outcomes. So let's let S be a sample space consisting of n equally likely outcomes, and let E be any event. Then the probability of E is the number of outcomes in E over n. So let's look at the sample space of rolling one die. I have 1, 2, 3, 4, 5, 6, right? That's my sample size. My sample size is 6. Let's let E be the event that I roll an even number. That means I've got 2, 4, 6 is my possible as part of event E. So how many outcomes are there in E? Well, there's 3. So the probability of E, which is rolling an even, is going to be 3 out of 6. So 1/2. Half the time you're going to roll an even. Here's explaining that a little bit in more detail. Okay. So let's say we have an urn containing white balls and 5 green balls. What's the probability of drawing, if you draw one ball, that's a green ball? So how big is my sample space? Well, my sample space has 8 balls in it and 5 balls, so my sample space is 13. How many ways could I draw a green ball? Well, there's 5, right? So the probability of drawing a green ball is 5 out of 13. Now, what's the probability of drawing a white ball? Well, there are 8 different ways for me to draw a white ball, so it's going to be 8 out of 13. So that was a nice, simple example. But what if I want to use some of our skills we learned in Chapter 5 about combinatorics? So let's say I have an urn with 7 white balls and 2 green balls. And if a sample of 3 balls is chosen, what's the probability the sample contains only white balls? So the probability of this event occurring is going to be the probability of only white balls out of my sample size, the size of my sample space. Well, what's the size of my sample space? How many options are there? Well, I have 9 balls total, so there's going to be 9, choose 3 different possible samples. And I want to know which ones contain only white balls. So how many ways can I take out of 7 white balls? Can I choose 3? That's going to give me 35 over 84. Next, I want to know what's the probability of the sample containing at least 1 green ball. So that for that, I need to know the probability of my sample containing at least 1 green ball. So if I have just 1 ball, that's going to be 2, choose 1. But then I have 2 balls left to choose, and that's going to come out of the 7 white balls. So this is just for the number of 1 green ball, and I have to add this to the number of 2 green balls. I also have to add this to the number of how many ways could I just get all green balls. Well, actually I can't, because I have to have a sample size of 3. So because I don't have 3 green balls, there's no way I could have a sample of only green balls. So I'm just looking at 1 and 2. So now I choose, that's supposed to be a C, not a parenthesis, 2 from the 2 balls times how many ways can I choose 1 white ball out of 7. So this is going to be 2 times 21 plus 1. See if 2 is 1. times 7. So I get 42 plus 7, which is 49. So the probability of me getting at least one ball that's green is going to be 49 out of 84. And I didn't simplify these two fractions because I can't simplify them any further. Next thing I want to discuss is the complement rule. So the complement rule relates the probability of an event to its complement. So let's let E be any event and E prime be its complement. Then the probability of E occurring is 1 minus the probability of E prime occurring. So for example, 1 is the probability of an event occurring and the probability of an event not occurring. So recall in our last example, if we let E be the probability that at least 3 balls selected are white, then E complement would be the event that at least 1 ball is green. If I was talking about dice rolls, I said E be roll an even number. E prime would be roll a odd number. So let's go through a complicated example. Okay, a slightly complicated example. It's really not bad. So let's say a group of 5 people is to be selected at random. What is the probability that 2 or more of them will have the same birthday? So for simplicity, we're going to ignore leap years and we're going to assume that everybody has the same likelihood of being born on each day of the year, right? There are some birthdays that are more popular, right? Like 9 months after Valentine's Day being one of them. So choosing a person at random, friendly reminder, is just as so because we're setting in these stipulations, choosing a person at random is equivalent to choosing someone's birthday at random. So how many ways are there to choose 5 birthdays? Well, if duplicates are okay, I have 365 choices for my first person's birthday, 365 choices for my second person's birthday, 365 choices for my third, fourth, and fifth person's birthday. That's going to be 365 times itself 5 times. Let's let our event, E, be the event that 2 or more birthdays are the same. That's kind of complicated to calculate. So let's first look at the complement. So the complement of the event would be that the 5 birthdays are different. Okay? So the number of possible outcomes where the 5 birthdays were different would be the permutation 365, pick 5. So I've got 365 options for the first birthday, 364 for the second, 363 for the third, 362 for the second, and 362 for the first, right? So I've got 5 different people. So the probability of that event complement is the number of ways that this can occur over the total number of possible ways of choosing birthdays, and I get 0.973. So there's a 0.973 or 97% chance all the birthdays are different. So the probability of our event, that 2 more birthdays are the same, can be found using the complement rule. So the probability of our event is going to be 1 minus the probability of its complement. It's 1 minus 0.9273, so I'd get 0.027. So about 0.3 or 3%. So if I choose 5 people at random, the likelihood of their birthdays, that at least 2 of them have the same birthday, is 3%.